Hello everyone, welcome back to my channel. This is your host Mohan and you are watching MS SQL DBA Crash Course. Today we are in part 3. Before that we have already recorded part 1 and part 2. So in case if you haven't watched those videos, please go through them. In part 1 we have explained about the fundamentals and DBA roles. In part 2 we have talked about the installation and configuration. We have installed the SQL Server and we have done some post configuration setting as well. In today's video, we are going to learn about the SQL Server architecture as well as system databases. And in the last, we will see the interview questions around this topic and explanation. So without any further delay, let's get started. If you are a DBA, I'm sure you have seen this diagram multiple times. In today's video, I'm going to explain the role of each and every component. We will see how a select query and an update query executes behind the scene and how these SQL Server components work to execute the queries. MS SQL is a server client architecture. MS SQL Server process starts with the client application sending a request. The SQL Server accepts, processes, and replies to the request with processed data. Let's discuss in detail the entire architecture shown here. As I said, the client connects to the SQL Server using the client application via the TDS packets. And what are those TDS packets? TDS means tabular data stream. So it is an application layer protocol. It is used for communication between the client application and the Microsoft SQL Server instances. A TDS packet is the fundamental unit of data exchange in this protocol. It encapsulates all the information, including SQL queries, RPC or remote procedure calls, responses, and the authentication details. And it also sends back the results to the client, which has been processed by SQL Server Engine. Now this SNI stands for SQL Server Network Interface. It serves as the protocol layer that handles establishment of network connections between the client application and SQL Server instances. This layer manages three communication protocol: shared memory, named pipe, and TCP/IP. And if you are wondering where you can find those protocols, so you can go into the search box and search for SQL Server Configuration Manager. You will see window like this, and here in the SQL Server Network Configuration, you can see the protocol names: shared memory, named pipes, and TCP/IP. So now let's understand each protocol. First is the shared memory protocol. So shared memory protocol is used for the local connections on the same machine. So if your client or app and your SQL Server both are installed on the same system, then we will use the shared memory protocol. But if your app or client and your SQL Server both are in the same LAN or local area network, then we use the net named pipe protocol. And if your SQL Server and your client or app is installed in different machines, which is located in different network, and you connect using the internet, then we use the TCP/IP protocol. So if you are a DBA, you must have seen most of the times in your machine where SQL Server is installed, your TCP/IP is always enabled. But here, as I am working locally, it is not enabled and it will still work because I am connecting locally. So now the output of this SNI refers to the processed TDS payload that it's hand over to the relational engine for further interpretation. So this language event type is a type of event or a message in SQL Server internal processing pipeline that represents a batch of SQL language commands. Now comes the relational engine. So this relational engine is also called as a query processor, and it is a core component of SQL Server architecture. It is just like a brain that handles the processing of queries after they have passed through the protocol layer. It is responsible for interpreting, optimizing, and executing SQL statements or commands received from the client. This engine ensures that queries are processed efficiently, securely, and in compliance with the relational database principles. It interacts closely with the storage engine to retrieve and manipulate data stored on the disk. So overall, we can see it receives the input from the protocol layer via SNI and TDS and sends results back through the same layer. Its primary goal is to transform high-level SQL queries into a low-level operations that the storage engine can execute while minimizing the resource usage like CPU, memory, and I/O. So the main component of relational engine are command parser, optimizer, and the query executor. Let's see what these components do. So first is the CMD parser or the command parser. This is the entry point for the queries entering into the relational engine. It receives the query text from the protocol layer. It will check for the syntax error and the semantics error. So syntax errors is like it will validate for the SQL syntax and the spelling mistakes. And if you have written the syntax incorrectly, it will give you the syntax error. But what are the semantics errors or semantic analysis? So SQL Server will check which table or index or view you are referring, and if that table is not present in that particular database, then it is called a semantic error, and it will give the error that object is not found. After it checks for the semantic and syntactic errors, the output of the CMD parser is a query tree that it will hand over to the optimizer. So this optimizer, often considered the most sophisticated part of the relational engine, this component generates and selects the most efficient execution plan for the query. It uses statistics about the data distribution to estimate the correct cost. It will first generate the execution plan. It explores multiple possible ways to execute the queries, such as it will use different join orders, different indexes, or scan types, and it will estimate the cost. It will assign cost to each plan based on the factors like IO operations, CPU time, and memory usage. Then it will choose the plan that has the lowest cost. This optimized plan is stored in the plan cache for reuse in the future similar queries. The optimizer can produce different plans based on the query hints, server configuration, or workload. Now comes the query executor. This component takes the optimized execution plan and executes it. It coordinates with the storage engine to fetch the data pages from the disk or from the cache, perform the operations like joins, sorts, and aggregations, and apply the filters. Execution happens in a pipelined manner where the data flows through the operators like hash join, nested loops in the plan. Once processing is completed, results are formatted and sent back to the client via the protocol layer. It also handles runtime errors, parallelism using the multiple threads for large queries, and the resource governance as well. Now comes the storage engine. So the storage engine is the lowest layer of SQL Server architecture. It is responsible for physically storing, retrieving, and managing data on disk while ensuring the durability, consistency, and high performance. While the relational engine is called the brain that decides what data to access and how to process it logically, the storage engine handles the how at physical level, reading from and writing to the files, managing the memory, managing the memory caches, enforcing those asset properties, and dealing with the concurrency. It interacts directly with the relational engine and the operating system for IO operation. The storage engine is what makes SQL Server reliable for production workloads. So what this storage engine does, it manages the physical data file like MDF and NDF and the log files like LDF. It manages the page level storage. It makes sure the data is organized into the 8K pages. It handles the indexing. It handles the buffer management, concurrency control, transactional logging, recovery. Everything is handled by the storage engine. First main component is the buffer manager. So this buffer manager maintains the buffer pool, or we can say in-memory cache of data and index pages. It maintains the dirty pages. What are the dirty pages? The dirty pages are the data blocks which has been modified in the buffer manager or buffer pool, but it has not been written to the disk or it has not been hardened to the data disk till now. Those are called the dirty pages. So the management of the dirty pages is being done by the buffer manager. It handles the background processes like checkpoints, lazy writer, and free page list. It also caches these plan. It also has the plan cache for caching the execution plan. This part is very crucial for the performance because most reads come from the memory instead of disk. Next is the access methods. So this access methods provides the interface for reading, writing the data rows, pages, and the indexes. It works closely with the buffer manager to fetch the pages into the memory. It supports different access patterns, like it can access the data row by row. It can use the index scans and index seeks. Next, we have the transaction manager. So basically, it has lock manager and the log manager. So in the lock manager, it enforces concurrency by acquiring or releasing locks at row level, page level, and the table level based on the isolation level of SQL Server. We will understand more about the isolation level later in this series. And the log manager. Log manager basically writes transaction log records before committing changes. That is called the write ahead logging. So this transaction manager ensures we have compliance with the asset properties, like that is atomicity, consistency, isolation, and durability. Then we also have a hidden part that is called the recovery manager. So recovery manager uses the transaction log to perform redo operation. It means reapplying the committed changes, and undo operation, that is rolling back the uncommitted changes during the crash recovery or during a database restores. So due to the recovery manager, we can support the point in time recovery. It also have other components like resource manager, IO subsystem, extents, and allocation. Now let's understand how a simple select query executes in SQL Server. First, the client formats the SQL query into a TDS or tabular data stream, and this packet includes query text, parameters, and metadata like an authentication details. The packet is sent over a network protocol, maybe TCP/IP, shared memory, or name type to the SQL Server instance. The SNI or SQL network interface on the server side receives those TDS packets. This SNI handles connection establishment and it decodes the packet. Then this decode payload is classified as language event or RPC event. Then this event is passed to the relational engine for the processing. So the command parser receives the language or RPC event and performs a syntax checks for errors. It resolves the object names like tables, column against the database schema and checks user permission. If valid, it generates a parse tree or query tree. If there is a syntax error, an error message is sent back immediately via the protocol layer. Then comes the query optimizer. The parse tree is fed into the optimizer. Using the statistics, it generates multiple possible execution plan. It estimates the cost based on IO, CPU, and memory, then select the optimal plan. The chosen plan is cached in the plan cache for reuse. Then comes the query executor. The query executor takes the optimized plan and begins execution. It requests specific data pages or 8 key units from the storage engine via the access methods. As the data is received, the executor applies operations like filters, joins, sorts, or aggregation in the pipeline fashion. Then it will send the result back to the client using the protocol layer. Then comes the storage engine. So the access method interface receives the request and checks for the buffer manager's buffer pool. Or we can say it will check in the in-memory cache. If the data page is in the buffer pool, we call it as cache hit and the information is returned immediately. If not, if this page is not found in the data in the buffer manager, the page is read from the disk via OS file system into the buffer pool. The lock manager still places a brief shared lock to ensure no one is changing the data while you are reading it, and the results are bundled into a TDS packet and sent back to you. So this is how a select query executes in SQL Server. Now let's see what will happen when we execute this query again. In this case, the query will be sent to the optimizer using the CMD parser, and this optimizer knows that we have a plan. An optimizer checks for the plans and it will found a plan in the plan cache because this query was executed in recent past. Then it will check for the data pages, and if the data page is found, it will send back the information to the client. But what if the data pages are not found in the buffer manager? It will again request that 8K page from the data file, and this page is being sent to the buffer manager and the information requested will be sent back to the client. Now let's see what happens when the update query executes. So the protocol layer and the CMD parser, everything will be same as the select query. and it will go to the optimizer. Optimizer will again check for the plan related to this query, and if it is not there, it will create a plan and it will choose the optimized plan based on the cost, query cost, and it will send the information about the query plan to the query executor, and then query executor will see that this data page is present. So here we are setting a salary to 60,000 for an employee where the employee ID is 10. In that case, it will first check that whether the related page is present in the buffer manager. If the related page is present in the buffer manager, then this page will be updated from the information in the page will be updated, and the salary is updated from 50,000 to 60,000. And at this time, the buffer manager sends the information to the transaction manager that we are making the salary from 50,000 to 60,000 in this data page, and this transaction manager will write the same information in the transaction log. Once we receive the information or the confirmation from the transaction log, then only this page is updated. And once the page is updated from 50,000 to 60,000, this is called the dirty page. We are writing in the transaction log before writing this page into the data file. This is called the write ahead logging, because we are writing in the transaction log first, and after the confirmation from the transaction log, we will be writing the information or the updation in this page, and later on, once the checkpoint will run, all those pages will be written to the data disk. Once the information is updated, the confirmation is being sent to the client. Now, in that case, if again it does not find the page in the buffer manager, it will go back and check in the data file, and this will be copied to the buffer manager, and it will make an update. And again, before making the update, it will write in the transaction log that this information is being updated, and then it will send back to the client. So this is how the update query works. So when this checkpoint executes, all the dirty pages which are present in the buffer manager, those are written back to the data files. This is how a SQL Server works, and this is how your SQL query is getting executed behind the scene. In SQL Server, system databases are special databases created during the installation. They store configuration, metadata, and operational information that SQL Server needs to function. As a DBA, you must understand each and every system database very well, because losing a system database can stop SQL Server from working. SQL Server has 5 system databases: master, model, MSDB, and tempDB. Those system databases are visible in the SQL Server instance, and there is one hidden or read-only database, that is a resource database, and we also call it as MS SQL System Resource Database. So let's understand about the master database first. So the master database is the brain of the SQL Server. Without the master database, SQL Server cannot start. And what master database stores? It stores the system level configuration setting. It also stores the information about all the databases on the instance, what are the database names, what are the file locations, and what are the status. It will also store information about SQL Server and Windows logins. It will have all the server level permissions. It will have endpoint information and the linked server information, and it also stores the system stored procedures. We also need to keep in mind that SQL Server will not start if the master is unavailable or corrupted. And there is only one master database per SQL Server instance. And if you are making any server level changes, it will always update the master by default. As a DBA, you must back up your master database regularly, especially after creating or dropping databases, or after adding the logins, or if you are changing any server configuration. If you want to restore master database, it requires SQL services to be started in the single user mode. Next is the model database. The model database acts as a template for all the newly created databases. It stores the default database settings. It has initial database objects like tables, stored procedures, and views. We can also set the file size and file growth settings of model database. And when you create a new database, SQL Server copies the model database to create the new database. So any object which is present in the model database, it will always be present in the new database. And the recovery model of the database will become the recovery model of the new databases. We always need to make sure that this model database is small and clean. It does not have unnecessary settings. And we also need to make sure that whatever changes you are doing in your model database, it will affect all the future databases. And if you are modifying it, we need to back up the model database. Next is the MSDB database. MSDB database is used by the SQL Server agent and other features to store the operational data. It stores the information about the SQL Server agent jobs, job schedules, alerts and operators, backup and restore history, database mail configuration, maintenance plan, and log shipping metadata. We have to understand that SQL Server agent depends heavily on the MSDB, and user queries should never modify MSDB directly. As a DBA, you must backup MSDB regularly. You need to clean the old backup and job history to avoid bloating. And the corruption of the MSDB can break the jobs, your maintenance plans, and the alerts. Next is the TempDB. The TempDB is a shared workspace used by SQL Server for temporary operation. So what this TempDB stores? It stores all the temporary table which you will create using hash. It will also store the table variables. It will be used for short and hash operations. It will also be used as a version stored in snapshot isolation. It will used for the reindex or rebuilding indexes. And the special characteristic of this database is that it recreates every time you restart the SQL services. It will always be in the simple recovery mode, and you cannot back up the temp DB. As a DBA, you should understand that this database is very critical for the performance, and you need to configure multiple data files as per your CPU cores, and this should be the proper size, and you should set the proper growth of this TempDB database. The last is a resource database. So resource database stores the system objects separately from the master database. And if you want to see the information about the resource database, you can go in the master database and you can run a query select star from sys.sysalt files. And here you will see the location of the data file and the log file of this resource database. As I said, this is a hidden and read-only database, and it has the system store procedures, system views, and system functions. And why it is existed here in the SQL Server? Because it makes the SQL Server upgrades easier, and it always allow fast recovery if the master is restored. And we cannot back up this database directly, and this will be backed up automatically when you back up your database. And it is a version specific. You do not copy those between the versions. So this is all about the system databases. Now here comes the most important part, that is interview questions. So first question will be, what happens in the background when you insert a row in a table in SQL Server? So you can reconfirm with the interviewer whether he or she wants you to explain it with the context of SQL Server architecture. If yes, then you can start explaining that first this query will be sent to the protocol layer using the TDS packets, and after that it will go through the protocol layer. It will be sent to the query, it will be sent to the command parser, and this command parser will check for the syntax and semantic error. And after that, this will be sent to the query optimizer, and query optimizer will check if there is already a plan in the plan cache, and if there is no plan, it will create multiple plans and it will choose the optimal plan based on the system resources, IO cost. And after that, this plan will be sent to the query executor. Then query executor will connect to the storage engine, and it will connect first to the access methods, and access methods will decide how it wants to insert the row. So access method will first check in the buffer manager whether that particular page that have that particular row or that particular tables row, it is there in the memory. And if the page is there and it has the capacity to insert row, it will insert that particular row in that page. Before inserting the row, it will log the information using the transaction manager to the transaction file that these are the records which are getting inserted. Once it gets the confirmation from the transaction manager that the information is written in the log, the insertion will be done in the page level, and the confirmation will be sent to the client back from the query executor to the protocol layer using the TDS packets. And if the page is not found, the page will be requested from the data file using the system IO, and after it is reached to the buffer pool, we will update the page. Before updating the page, we will write the information in the transaction log. So by this way, you can explain the whole architecture of the SQL Server. The next question is, what is the primary job of query optimizer, and is it looking for the perfect plan? So in that case, you can answer that that the query optimizer's job is to generate an efficient execution plan, and it does not look for the perfect plan or the best plan, as that could take hours. Instead, it looks for the good enough plan, or you can say it looks for the optimal plan based on the cost. The next question is, what is the buffer pool and why is it the largest consumer of memory in SQL Server? So you can explain that buffer pool is a cache in RAM that stores the data pages. SQL Server never works directly on the disk. To read or update a row, the page must first be pulled from the disk into the buffer pool. And why it is important? Because reading from RAM is thousands of times faster than reading from a disk. A buffer cache hit ratio is the configuration, or is the setting, or is the number that tells you how often SQL Server finds the data in memory versus having to go to the disk. The next is, what is the plan cache and how does it differ from the buffer pool? So in that case, you can answer that buffer pool stores the data or the data pages. The plan cache stores the execution plans. So when the query is submitted, SQL Server checks the plan cache first. If it finds the plan, this is called the plan cache hit. It skips the expensive optimization phase and reuses the existing plan. This saves the significant CPU cycles. Now, the next question may be to confuse you that my TempDB log has grown to 120 GB, and is it a good to take log backup to resolve the issue? Here, you need to first uh, completely understand what he is trying to ask. He or she is trying to confuse you because, as we know, that TempDB does not. We cannot take that backup of TempDB, so you can simply say this is a TempDB. We can find the another approach, we can apply the another approach, but this log backup or any kind of backup will not work in TempDB. The next is, which database is responsible for SQL agent jobs? So the answer is very simple. It is MSDB. So this is it for today, and I'll see you in the next video. Till then, take care.